Welcome. This lesson is our second part of a lesson over proportion. Let's look at our number routine. Jessica can do 60 push sit-ups in 2 minutes. That's pretty good. Dale can do 150 sit-ups, but takes him 5 minutes. Are these rates equivalent? Make a table if you want. So how can you tell me if these are equivalent? Many ways you can do this. Let's use Jessica first. I'll call her Jess. And let's do Dave. Some of you may prefer unit rate. So this is about sit-ups and this is about minutes. So Jessica could do 60 sit-ups in 2 minutes. I want to figure out how many sit-ups can she do in 1 minute. Would you like to go find a relationship up and down or side to side? It's up to you. I'll do up and down, I guess. How do you turn a 2 to a 60 times 30? So the scale factor is times 30. So she can do 30 sit-ups every minute. Dave, sit-ups, minutes. Dale can do 150 sit-ups in 5 minutes. How do you turn 5 to 150? That's times 30. Hey, that's the same scale factor. So they are equivalent. They both can do 30 sit-ups per minute, each minute for every 1 minute. So we're going to be doing something called hit the dot. So in hit the dot, you try to think of it as whack the mole. I don't know if you ever played this at a amusement park, uh, entertainment, Times Square, and or 99. But you try to hit as many moles or dots here. Imagine that these are the mole heads as fast as you can. Every time you hit the wrong dot, you will lose a score. Ah, I got a score of 33. So 33, submit. Let's see, how do I compare to the rest of America? So I hit 33. Oh, I'm in the average. Hey, 22% of Americans can do it. Whoa, wow. Some people, so not bad at all. Some in the upper part, so only about 11, 12, 13, 14, 15, 16, 17. About 17% of Americans who've tried this, or anybody, people who've tried it, are better than me. Not bad at all for me. Heck. So let's hit the dot. So Mr. Joe was able to do 33 dots. So student one hit blank dots in 30 seconds. Who was it? It was I. I was able to hit 33 dots in 30 seconds. If student one keeps the same pace, right, how many dots will he hit in 90 seconds? So I was able to do, this is about dots and seconds. I was able to do 33 dots in 30 seconds. What is the, do we have an up and down relationship right here? Between? No, we have one within. What is the scale factor from 30 seconds to 90 seconds? The scale factor is times 3. So 33 times 3 is 99 dots every 90 seconds. So if I kept the same rate, the same steady pace, this is what I could do. So let's look at our next screen. Student 2, well, I'm going to have to make up some numbers now because I was the only one who was doing it. But student 2 was able to hit 35 dots in 30 seconds. If student 2 keeps the same rate, how many dots can he or hit in 3 minutes? Ooh, 3 minutes. What is 3 minutes? Let's see, 60 seconds every minute, 60 seconds per minute, 60 seconds, that's 180 seconds. What is the relationship from 30 seconds to 180? It is times 6. So 35 times 6 is 210 dots in 180 seconds. So what we've been doing for the last few lessons are creating a table. I like table. It organizes the information. But there is something called proportion. Proportion is the same idea. Instead of making an array, a rectangular array, or such as this, a table, you just input the information in this proportion. Same concept. So it's 35 dash or over 30 and here and 80, and x means we do not know this number. It's a missing number. X is called a variable. So same idea. What's the relationship from 30 to 180? Times 6 times 6, 35 times 6, x will be replaced with 210. So for the rest of the lessons, or actually for my class, if you are comfortable with making tables, or you're comfortable doing proportion, either one is acceptable. I'll be honest, I prefer the table because it has more information, more easier, more space to write, but it's the exact same idea. One of the students hit an even number of dots. We'll just say they hit, I don't know, 24 dots in 30 seconds. Who was it? It's a make-believe person. If the student keeps the same rate, how many dots will he or she hit in 45 seconds? What's the relationship from 30 to 24 or 24 to 30? Is that even possible? Oh, so this is a table. Maybe you prefer writing it as a proportion instead. In a proportion, you just have to make sure the labels. 24 is about the dots. These are about the seconds. You know what? I'm going to try this relationship. What's the relationship from 30 to 45? Some of you may say 1.5. If you can go to 1.5 as a scale factor, that is awesome. However, some of you may not be able to do it that. So you know what? What type of numbers do you see for 24 and 30? Aren't they even? Could we simplify this? Oh yeah, we could simplify it. So we could divide both numbers by 2 or times it by a half, because dividing by 2 is the same thing as multiplying by its reciprocal. So 30 halves is equal to 15. 24 halves equals 12. Now, what's the relationship between 15 to 45? Times 3. Times 3. So they're able to hit 36 dots in 45 seconds. So you do the same concept right here, just like you did. 24, 30. Half of it is 12 and 15. What's the relationship between 15 to 45? Times 3. And that's where you get 36, 45. Again, your choice. One of the students hit an even number of dots, so let's do, I don't know, 22 dots in 30 seconds. Who was it? Make-believe number 2. Is there a relationship between, oh, let's put it here, 22, 30, 75, x. We do not know that missing number yet. Can 30 go into 75? 22 go into 30? No. But what type of numbers do you see right here? They're even. I think I can simplify this. Oh, so I times it by a half. Times it by a half. So that's 11, 15. So what is the relationship between 15 to 75? Times 5. Times 5. It is 55 dots in 75 seconds. So what we just did is we practiced with proportion or tables. So let's read this question. Alex read 4 pages in 6 minutes. So here's a table at 6 minutes. So let's break this up into 4 sections. And 1 page, he read 1 page. He read 2 pages. He read 3 pages. Now he read 4 pages. So it took him 4 pages, 6 minutes. So we just labeled it. Predict the number of minutes it will take Alex to complete 6 pages at the same rate. So how many minutes will it, can you find a unit rate? How many minutes will it take him to read each page? So we can divide 6 minutes by 4 pages. It goes in 1 time. 2, annex a decimal 0. 4 goes 25 times. So it takes some 1.5 minutes for the first page, 1.5 minutes for the second page, 1.5 minutes for the third page, 1.5 minutes for the fourth page. So if you had to read another page, 1.5 minutes, and another page, 1.5 minutes. So 6 pages, 1.5, 1.5, 1.5, 1.5, 1.5, 1.5, plus 1.5, plus 1.5, plus 1.5, plus 1.5, plus 1.5, plus 1.5. Well, these are 3, these are 3, these are 3. So it takes them 9 minutes to read 6 pages. That's one way you do it. Maybe you prefer to make a table because it's neater. Be honest, I prefer the table. Um, so pages and minutes. It took 6 minutes to read 4 pages. But I want to, wait, is that correct? You have 4 pages, 6 minutes. How many pages, how many minutes will it take them to read 6 pages? Can 4 go in 6? Not quite. Can 4 go into 6? It can, but I wanted to use uh, more simpler, easier numbers. Look, oh, these are, we can simplify this. 2, 3. The relationship is times a half. Then what's the relationship between 2 to 6? Times 3. So 6 times half is 3. 3 times 3 is 9. Again, if you do not prefer to make a table, maybe you prefer to have create a proportion. Same idea. You have to simplify 4 and 6. That'd be 2, 3. Then what's the relationship from 3 to 9? Times 3. That's where you get 6. All right, so there are 3 ways you can solve this. Do you prefer the bar diagram? Do you prefer a table? Do you prefer a proportion? Please choose one. Sarah can type 90 words in 4 minutes. That's really slow. About how many words would you expect her to type in 10 minutes at this rate? You know what? I like the table. Not to say that I am pushing you to use a table, but I prefer the table. So she can do 90 words in 4 minutes. About how many words can she do in 10 minutes? Can 4 go into 90? I believe it can go into it. So how many 4s go into 90? It goes in twice. Oh, maybe not. Can 4 go in 10 2 times? Let's annex a decimal 0. 4 go 20. So it goes in 20. The scale factor is times 22.5. What is 10 times 22.5? 0, 0, 0, 5, 2, 2, 0, 5, 2, 2. There's one number behind a decimal point, one number. So it's 225. That's one way you could have done it. However, is there a simpler way of doing this? Oh, we could simplify this. Divide both numbers by 2 or find half of it. And then a scale factor of times 5. Oh my God, it's so much faster. 45 times 5 is 225. And Mr. Joe cut 120 yellow roses in 30 minutes. So at this rate, how many roses can he cut in 2 hours? So I cut roses and minutes. 120 roses in 30 minutes. 2 hours. What's another way to say 2 hours? Well, not 60 minutes. That's an hour. 120. What's the scale factor here? Times 4 times 4. 480 roses. Dang, I must be using a machine to do this. Maybe you don't prefer a rate table. Maybe you prefer writing it as a proportion. Same idea. How do you turn 30 to 120 times 4? 120 times 4, scale factor, that'd be 480. And here are our last 2 questions. In a survey, 3 out of 5 people prefer jelly over peanut butter. There are 120 people shopping at the grocery store. Use the survey to predict how many people in the store would prefer peanut butter. So this is about people who love jelly and a number of people. So 3 people like jelly out of 5 people. What's the relationship between 5 to 120? How many 5s go into 120? It goes in 24 times. So the scale factor is times 24. three groups of 24, I believe it's 72 people prefer jelly out of 120. Now let's get to something a really harder. This one, I do recommend you use a table in order to solve these kind of questions. There are 12 boys and 8 girls in Mr. Thomas' class. At this rate, if there are 800 students at the school, how many will be girls? So what is this about? This is about boys, girls, and students. Boys, girls, and students. There are 12 boys, 8 girls. We need to figure out how many girls there are right here out of 800 students. Can we figure out this part right here? Her class, in his class, how many students does he, there are 20 students. So what is the relationship to 20 to 800? You could say times 40 if you could figure it out, because 20 goes into 800. Let's make sure I am correct, 40 times. But however, you may not think that large. What about going in incremental steps? How do you turn 20 to 100 times 5? So it'd be 60 here and 40 here. Then how do you turn 100 to 800 times 8? So 40 times 8 is 320. 60 times 8, 6 times 8 is 480. So how many girls? 320 girls out of 800 students. And our last example. In a bag, the ratio of oranges to apple is 3 to 7. Based on this ratio, how many oranges are there in a bag if there are 50 fruits? So we need to know oranges and fruits. But they give us apples, so that must be an important part of our table. So there's 3 oranges to 7 apples, 10 fruits. What's the relationship between 10 fruits to 50 fruits? Times 5. So this would be 15. This would be 35. Together it adds up to 50. So how many oranges out of 50? 15 is the answer right there. So what we just did is proportion. Make a table. Make a proportion. What do you prefer? And find its relation.